Hello students, and welcome to today's lecture where we are going to cover the topic of polyatomic ions. So polyatomic ions are a new topic for us, and it's a new kind of mainly an ion that we're going to be working with. Okay, so what we're going to do first is we're going to go ahead and define what a polyatomic ion is. And a polyatomic ion is going to be an ion that is composed of multiple elements. Okay? So that's what a polyatomic ion is. Now, we're going to go ahead and show one here. And we're going to go ahead and go with one of the more common ones. And this is going to be the carbonate ion. Okay? And the carbonate ion has 1 carbon, 3 oxygens, and this entire compound right here will have a double bond and has a charge of 2 minus. Okay? So that means that when all of this ends up coming together here, what will happen is that we're going to have a 2 minus charge. Alright? And if I don't draw these lines, it'll annoy me a little bit. Okay. So, this is an example of a polyatomic ion. Now notice this ion has 1, 2, 3, 4. It has 4 different elements in it. Okay? It has 4 different atoms in it. Alright? It is a many atomic ion. Okay? Now, let's go ahead and work with this ion. So this is going to be CO3. And this is 2 minus. Okay? So let's say that we take, a regular compound. Let's go ahead and go and say that we have sodium. Okay? And let's make some sodium carbonate. Okay? Sodium, we can go ahead and look back and say, oh, okay, sodium's plus 1. Okay? And now what we can do is we can do the exact same process that we've been working with earlier. Except this time we're going to have this carbonate ion. And this ion, it's going to stay together, okay? So in general, for these ions, when we're messing with them and bonding with them, I want you to notice that it's in this nice little prison here, and it's going to stay in that prison, all right? So that means that we're going to go ahead and take our 2 from over here, our 1 from here, and we're going to move them just like we did with all of our other ones. So we'll have Na, the 2 will go here, and then we'd have our parentheses CO3. And then technically we would have 1, alright? Now at this point we know that we have to clean this up, and we're going to do 2 things to clean this one up. The first thing, we have to get rid of that 1, because, we're lazy. We don't want to have that 1. The second thing is that these parentheses, if there's only 1, we'll go ahead and get rid of them. Which means that our final compound will be Na2CO3. Okay? And this is the basis for going through and doing polyatomic ions. And they can end up bonding the exact same way as all the other ones. And we have a whole bunch of them that we can go ahead and work with. In fact, here, nope, that's not the one I want. No. Here is a list of some of the common ones, okay? And notice there's a whole lot of them, all right? There's acetate, ammonium, arsenate, and, normally during the school year, I would end up giving you guys a cheat sheet that has all of these here. So what I'm going to want you to do is make sure that you guys have this cheat sheet somewhere close, either in your bookmarks or you have like a little tab that you can go ahead and open it up. because throughout this year, you're going to have to go ahead and work with these at least a little bit, okay? There are some that I am going to expect you to know, though, okay? Some of the polyatomic ions that I'm going to expect you to know are going to be ammonium, which is NH4, and that's a positive ion, okay? So that's a positive one. NO2 minus, this is nitrite. Notice that it's going to be nitrite, so that means that it's going to be a negative ion. NO3 minus is nitrate. Now I want you to notice that the names of these have changed, okay? So notice this isn't something that ends in nitride, or it's not nitrogen, it's nitrate. Which means that whenever you see something where it ends with ATE or ITE, you should automatically think that it is a polyatomic ion. So here we have sodium carbonate. Notice that it has ATE. All of these have either nitrite or nitrate. And that's how we differentiate them from their single molecule counterparts. Okay, so the ones I need you to memorize, though, are ammonium, nitrite, nitrate, sulfite, sulfate, hydroxide, phosphate, carbonate, chlorite, chlorate, acetate, permanganate. This one's a really fun chemical to work with, by the way. Dichromate, chromate. Okay, so ammonium, nitrate, nitrate, nitrite, sulfite, sulfate, hydroxide. We're going to use this one so much it's not even funny. Phosphate, carbonate, chlorite, chlorate, acetate, dichromate, chromate, and permanganate. Alright, so let's go ahead and just do another example. Let's go ahead and do one that's in your bones, and let's work with calcium phosphate. Okay, so calcium phosphate. Here, we'll go ahead and have calcium. And phosphate, we're going to have to look back, and we're going to have to look back and see, all right, what is phosphate? Okay, phosphate is PO4, and that's 3 minus. So let's go back here. PO4, 3 minus. All right, so we have calcium, we have phosphate, and we have to find calcium here on our periodic table, and it looks like it's in the 1, 2, it's in the second row. So we'll go ahead and go 2 plus. And then just like before, we're going to go ahead and crisscross. So the Ca will get 3. The PO4 will get 2. And here, since we have 2 here, this 2 goes to everything that's in here, and we want to leave it that way. So this is now our answer. So if you have any number other than 1 here, it keeps those parentheses. And that's it. Okay? Now, let's go ahead and work on a harder one. Let's go ahead and work on one that uses one of our transition metals. Let's do vanadium. Oh, let's actually type it out well, though. Vanadium 4 dichromate. Okay. So, wow, this one sounds like it's super complicated, right? Vanadium 4 dichromate. All right, so let's go ahead and just break it down. We need vanadium, which is going to be V, and we're going to need dichromate. Okay, so dichromate here, it's Cr2O7 and it's 2 minus. Oh gosh, it's a whole lot there. Cr2O7, and this entire thing is 2 minus. Okay, now this thing, it's going to stay the exact same. Okay, so we put it in here, it doesn't move. Now vanadium, got to figure out what vanadium is. Oh wait, no, vanadium, it's a transition metal. It tells us what it is, so it's 4 plus. Okay, we do our crisscrossing. So we'll have V2 Cr2O7. This is 4. Okay, and then we notice, hey, wait a minute, 2 and 4, those aren't lowest terms, so we'll go ahead and have to knock them down. Okay, and this would be 1, but we're not going to write it because we're lazy. And then this now turns into 2, because we've reduced it. We divided both by 2. Okay? And that's really it for polyatomic ions. Alright? Now, I'm going to be perfectly honest. These two combined, the transition metals and the polyatomics, are the thing that most often gets students in this section. However, as you guys can see, we just kind of treat them the same. Except that we don't even have to count, like we already know what they are. Now some of you might have some issues memorizing it, but one thing that might help is that whenever it's an 8, that means that it's going to automatically going to be the thing with the most oxygens to it. So for instance, sulfate has 4, sulfite has 3. And that's just one little trick that I like to use to go ahead and help us memorize it there. And then one last reminder to the ones that we're going to have to memorize. And we're going to memorize these because we are going to use them so often that going back to look at a table is going to be more work than if we just memorized them. Okay? They're going to be ammonium, which is going to be NH4, nitrite, nitrate, sulfite, sulfate, hydroxide, phosphate, carbonate, chlorite, chlorate, acetate, permanganate, and then dichromate and chromate. Oh, and then permanganate. This one's really fun. Alright, and I'll show us a reaction with that one. Alright, but for right now, we're going to go ahead and close down. This should be something that should be easy for you to go ahead and start working on your homework for this section, which should be just a really short, little section with naming with polyatomic ions. All right? And I hope you all have a good one, and remember, be lazy.